Welcome to NextEra Tech. Today, we're taking you deep inside one of the most advanced pieces of aerospace engineering ever conceived, the Falcon-9X. A name that's now echoing across hangars, control rooms, and launch pads around the world. The Falcon-9X isn't just another rocket, it's a statement. A promise of faster, safer, and more efficient access to orbit and beyond. For decades, humanity's greatest challenge in spaceflight has been reliability and reusability. Every launch used to mean rebuilding the same hardware at staggering costs. Then came a revolution, rockets that could come back home, ready to fly again. But the Falcon-9X takes that idea and pushes it into an entirely new dimension. So, what exactly is Falcon-9X? Picture a next-generation orbital launch system, sleek, tall, and powerful. Standing at just over 70 meters, it towers like a silver spear against the horizon. Every inch of its frame is built with purpose: lighter alloys, composite tanks, adaptive avionics, and intelligent thrusters that almost think for themselves. At its heart lies the Raptor-X engine cluster, 9 main engines, each one a miracle of engineering. These engines are powered by a revolutionary methane-oxygen mix, giving cleaner combustion, higher efficiency, and far greater reusability than any kerosene system before it. When they ignite, they generate more than 7.5 million pounds of thrust, lifting more than 25 tons into low Earth orbit. But raw power isn't what truly defines the Falcon-9X, precision does. From the moment it leaves the launch pad, every microsecond is controlled by an artificial intelligence system capable of reading thousands of data points in real time. This AI not only corrects flight trajectory but predicts atmospheric turbulence before it happens, adjusting fin angles and engine throttles with near-human intuition. And when it's time to return home, the spectacle really begins. The booster stage performs a high-altitude flip, reignites 3 engines, and guides itself through the upper atmosphere. Its titanium grid fins spread like metallic feathers, steering the rocket through re-entry plasma. Then, with stunning grace, it touches down vertically on a drone ship in the middle of the ocean. It's not science fiction anymore, it's precise engineering in motion. One of the Falcon-9X's greatest achievements is its turnaround time. Traditional rockets needed weeks, even months, for refurbishment. Falcon-9X can be checked, refueled, and ready to fly again in under 72 hours. That's a game changer. Imagine a rocket that can launch multiple payloads within the same week: satellites, cargo, or even crew missions. This capability makes space access as routine as commercial flight. The upper stage of the Falcon-9X is equally impressive. Fitted with a single vacuum-optimized Raptor engine, it's designed to carry payloads deeper into orbit, geostationary transfer, lunar trajectory, even interplanetary injection. The stage is fully automated, with adaptive heat shielding for controlled re-entry and recovery. For the first time, both stages of a heavy-lift rocket can be reused repeatedly, slashing costs and reducing waste. But the Falcon-9X isn't just a rocket, it's a system. Around it exists a complete digital ecosystem known as NovaNet. This cloud-based network connects the rocket, the control center, and even the launch infrastructure through encrypted quantum communications. Every sensor, every thruster, every valve is connected through NovaNet, enabling engineers on the ground to see the entire system as a living digital twin. If a single component shows irregular data, the AI analyzes and suggests fixes before launch. And then there's the human factor. The Falcon-9X capsule, known as Horizon, has been designed with both crew and cargo in mind. Inside, it's a fusion of minimalism and safety: touchscreen interfaces, smart pressure regulation, and an adaptive life support system that can adjust oxygen and humidity based on crew stress levels. Every surface is coated with acoustic damping material to make the cabin almost silent during ascent. For the astronauts, it's not just a journey, it's an experience. Beyond its technical brilliance, the Falcon-9X represents a shift in philosophy. The world of space exploration is no longer limited to government agencies and multi-billion-dollar contracts. Private technology has democratized space. Smaller nations, universities, and startups can now send experiments and satellites into orbit at a fraction of the previous cost. The Falcon-9X opens that door wider than ever before. The rocket's environmental design is another major leap forward. Methane fuel drastically reduces carbon residue, and the reusability factor means far fewer launches produce waste materials. Even the exhaust plume is cleaner, releasing fewer particulates into the atmosphere. The goal is a sustainable space industry, one that doesn't trade progress for pollution. Of course, creating a machine of this scale isn't without its challenges. Engineers faced intense vibration issues during early tests. The first prototypes struggled with aerodynamic instability at transonic speeds. But each failure was met with iteration, not retreat. The team rebuilt components, retuned algorithms, and refined materials. The result is a rocket that now stands as one of the most stable ever launched. When the first Falcon-9X lifted off from Cape Canaveral, the world watched in silence. The engines roared, the sky lit up, and within minutes, the booster had detached and begun its descent. 10 minutes later, it landed perfectly, with the precision of a ballet dancer. Crowds erupted, engineers cried. Decades of work had turned into a single moment of triumph. Today, Falcon 9X missions serve not only commercial clients but scientific institutions and planetary research programs. The same rocket that places communication satellites in orbit can also send probes to study Mars or the outer planets. Its modular design allows rapid adaptation. Different fairings, cargo bays, or crew modules can be swapped in hours. Flexibility is its superpower. Looking ahead, the Falcon 9X program is paving the way for something even bigger: interplanetary transport. The technologies perfected here will form the backbone of humanity's next great leap: sustainable colonization of the Moon and Mars. Every flight, every landing, every data stream brings us closer to that dream. For space enthusiasts, the Falcon 9X is not just a rocket. It's a symbol of progress, of resilience, and of the human desire to go further. It reminds us that technology isn't just about machinery and metal, it's about imagination and courage. At NextEra Tech, we celebrate these milestones because they show what's possible when innovation meets determination. The Falcon 9X is proof that the future isn't waiting to arrive, it's already here, burning bright across the night sky. So next time you look up and see that trail of fire disappearing into the heavens, remember, it's not just a rocket you're watching. It's a bridge between worlds, between what we once dreamed and what we can now do. Thank you for watching NextEra Tech. If you enjoyed this deep dive into the Falcon 9X, make sure to like, subscribe, and tap the bell icon so you don't miss our next journey into the future of technology. Because here, at NextEra Tech, tomorrow begins today.